is Leandro Alexis Lolo. I am an IT student of Davao Oriental State University. Disclaimer lang po, hindi po ako magaling na IT student. And today, I am presenting a laboratory on mini system integration from data to functionality. So which is in this case, I will be using a data integration. Now, think about your university. The registrars maintain students' records, but human resource needs that data too. How does that data flow? What formats does it use? How do they stay synchronized? That is system integration. Real organization face this daily, which is the system integration. For example, the university registrar, human resource system, finance system, e-commerce inventory, website, and analytics. We have three main approaches. Number one is functional integration for direct method calls, which is the tight coupling. Second one is presentation integration, shared UI layers. And the third one, which is the one that we use, data integration, exchange is standardized data. We chose data integration because subsystems don't need to know about each other's implementation. Can change one system without affecting the other system. Systems don't need to run simultaneously, and system B can read data even when system A is offline. For its scalability, 10 consumers can read from one provider, easy to add new system without modifying existing ones. Now, JSON is universal. Any language can parse it, such as Python, JavaScript, C Sharp, Java, all understand JSON. This is how enterprise system actually integrate the system integration used by REST APIs, message queues, ETL pipelines, and data lakes. Let us now proceed with technical implementation. So this is basically a walkthrough of the code. So let me show you the key components. For example, the student Java ensures both system use compatible data structure for the fields such as the student ID, name, email, department, general point average, and enrollment year. This is crucial, both sides must agree on the format. For the subsystem A, maintains list of 5 sample students, and methods such as get all students, yawa ngayon ko, get all students, uh, get students by ID, get students by department, get total students, calculate average GPA. So that's all the methods that we use. Simulates a real database backend. Source of truth data originates here sa data provider. In subsystem B, student display consumers. This is where the students yawa for the subsystem B. This is where the students' data is received, display using methods for and multiple views of same data. The next one is the integration layer, data exporter. So the job of the JSON data exporter converts students object to JSON strings, and for the JSON data importer converts JSON strings back to students object. Di ba? Ang galing. For this case, I uses regex pattern for parsing, which is no external dependencies needed. Handles serialization and deserialization. Now, here's a quick demonstration of our system. Let's try to run and evaluate the system. Notice let's use number one, display all the students. Kita ninyo? Number 1. So notice how the data are provided. So this data flows from subsystem A to JSON to subsystem B, which is the display. Ani. Now let's try a summary statistic. Number 2. For the summary statistics, it is also shares by the same data, which is yung natawag na to nga data integration. Same ng flow niya from system A to JSON to system B. The data has been transformed from JSON back to the student's object. Now, show the output. Now let's try about filtering by department. We have 3 departments, which is engineering, business administration, computer science. Let's try engineering. Okay. See, what happens here is that this is also from subsystem A that flows from JSON back to the student's object and displayed in the subsystem B. So that's how the flow. Sabay lang sa flow. Now let me show you the actual data file of JSON. So it's number 6. So here are the contents of the JSON file. Timestamp. Mano sila ang mga content sa JSON nga data file. Our JSON file is the foundation of all these concepts. For the technical challenges and solutions, including this lab. So, the problem. Okay. Let me summarize what I have demonstrated. Number 1 is the system integration is fundamental. Every organization has multiple systems. They must communicate somehow. Integration quality directly impacts business outcomes. Data integration is most practical. Loose coupling between systems allows independent evolution, scales to many consumers, real-world standard, APIs, ETL, message queues. Standardization is critical. Both systems must agree on formats such as JSON, XML, protocol buffers, which is, in this case, ang igamit na ko is JSON. For the transformation is the hard part. So, from pag-transfer sa data format compatibility from subsystem A to JSON to subsystem B. Enterprise patterns matter. Well, foundation, understanding real world, wala na ni. So I have a question. Why not just use shared database? Good question. Shared database creates tight coupling. Schema changes requires coordinating both systems. System A issues can lock system B. Can't easily add new consumers. Doesn't work across different network domains. But yes, for tightly integrated systems, shared database is an option. The next question is, what about real-time requirements? Sub-second latency. A file-based JSON is too slow. You would use message queues, activate MQ, rabbit MQ for streaming. Now, what if the data is sensitive, such as financial? Encryption in transit is needed. Encryption at rest, database encryption is required. Authentication, authorization, audit logging, and data masking. So, tama to, muna to, at least nagkaila ta. Aray mo. Sa mga nanonood, boto no kado. 5-0 para kay Leandro, magingay.